If the product is insoluble in water, we want to use separation to remove water-soluble impurities from a product. So what we want to do, pour mixture into a separating funnel, add water. Shake the funnel, allow it to settle. The organic layer and aqueous layer are immiscible, aka they don't mix, therefore it separates into two distinct layers. Open the tap and run each layer off into a separate container. If the product and impurities are both soluble in water, you want to use something called solvent extraction. So we want to take the organic solvent, which product more soluble in water, add to impure product solution and shake well. The product dissolves into organic solvent, leaving impurities dissolve in water. Solvent containing product then run off using separating funnel. Then we want to remove water from purified product by drying it. So we want to add anhydrous salt, magnesium sulfate, MgSO4, calcium chloride. It's better if you know both the examples of anhydrous salts, because it could ask you, I guess, to name one. And the salt is a drying agent. Salt is a drying agent binding with any water present. As the salt is binding with any water present, it's becoming hydrated. Keep adding the drying agent until it disperses evenly when swirling in the flask. Filter the mixture to remove solid drying agent, aka a piece of filter paper and funnel feeding into a flask, and pour mixture in filter paper. Filter paper can be fluted. The concertina folded, therefore increasing the surface area. We can remove other impurities by washing it. Now what this means is by washing the product, we're adding another liquid and shaking it. We're not actually like washing it. So removing other impurities by washing it, adding another liquid and shaking it. As the products of reaction are contaminated with leftover reagents volatile liquids can be purified by distillation. Well, what does distillation do? It separates liquids with different boiling points. So, if we connect a condenser to a round bottom flask containing the impure product in solution, then we want to place the thermometer in the neck of the flask so the bulb sits next to the entrance of the condenser. The temperature on the thermometer will show the boiling point. This is a really key thing. The temperature on the thermometer will show the boiling point of any substance evaporating at any given time. You want to heat the impure product, and when the products want to collect, boils, you want to place flask at open end of condenser to collect the pure product. And this is the distillation apparatus to purify volatile liquids. So you get thermometer, water out, water in, condenser, impure product, heat, and the pure product. Organic solids can be purified by recrystallisation. And we want to add a very hot solvent to impure solid until it just dissolves. The reason we don't want to add too much hot solvent as it will give a saturated solution of impure product. So don't add too much hot solvent as it will give a saturated solution of impure product. And this is how organic solvents can be purified by recrystallization. You want to filter the hot solution through a heated funnel to remove any insoluble impurities. Leave the solution to cool down slowly, and you can see crystals of products forms as it cools. We want to remove the liquid containing soluble impurities from the crystals, and how we do this by filtering the mixture. Remove liquid containing soluble impurities from the crystals by filtering the mixture under reduced pressure. Pour the mixture into filter paper lined with the Buchner funnel. Pour mixture into filter paper lined with Buchner funnel sitting inside of the arm flask attached. Wash the crystals with ice. The cold solvent is used to remove any soluble impurities. And this should say pour mixture into filter paper lined Buchner funnel sitting inside arm flask attached to the vacuum line.